Okay, good morning, everyone. This is Gianluca Ruffato from the Department of Physics and Astronomy of the University of Padova. I'm here today with Dr. Claudia Cecchetto from the Department of Biomedical Sciences and Dr. Andrea Vogliardi from the Department of Physics and Astronomy. It's a pleasure for us to welcome you to the seventh FNIP webinar, the first of this new edition of 2023 and 2024. Before starting, let me introduce a few details regarding the FNIP platform. FNIP stands for Fluorescence Neuroimaging and Photonics. It is a scientific platform created to bring together scientists and young researchers working in the field of advanced microscopy, imaging techniques, and photonics. It is a very interdisciplinary program covering the three complementary levels of photonics, microscopy, and data analysis. Behind the organization, we are a group of at least 7 researchers from different departments and institutions, in particular the Department of Physics and Astronomy, the Department of Biology and the Department of Biomedical Sciences of Padova University, and the Neuroscience Institute of the National Research Council. So far, about 23 speakers from all over the world joined this initiative in previous webinars and events. If you are interested in the program, you can connect to the official website where you can find information of previous events, speakers, you can find the records of previous initiatives, and also you can be updated on the upcoming events. You can also don't hesitate to contact any one of us if you are interested to join the initiative as a speaker, as an organizer, or a supporter. A few details before we start. If you want to ask a question, please use the Q&A button during the presentation. We will try to address some of the questions at the end of each presentation, depending on the available time. Otherwise, the speaker will be able to write down the answer directly later. At the end of a free presentation, there will be a follow-up session. Oral questions are allowed only during the roundtable, so in this case, please raise your hand and we will enable your microphone. We will try to give priority to young researchers and PhD students, so don't be shy and take the chance to interact with people expert in the field of today's topic. If you have any questions now, or I think we can start with today's session. We are in the framework of photonics. The topic is that of metasurfaces. We thank all the speakers for joining us today. The first speaker is Dr. Auran Ren from the School of Physics and Astronomy of Monash University in Australia. The second speaker will be Professor Andrea Di Falco from School of Physics and Astronomy of St. Andrews University in UK. The first speaker will be Professor Jung-Suk Roh from Pohang University of Science and Technology in South Korea. Why a FNIP webinar focused on metasurfaces? In the last years, the research interest on metasurfaces and their applications has increased exponentially, and metasurfaces and metalenses in particular have been recognized in 2019 among the top emerging technologies as a new revolutionary way to manipulate and control light, with widespread applications from life science to information communication technology. At the first glance, metasurfaces may appear as the last stage in the process of miniaturization of standard refractive optical elements by substituting the still three-dimensional profile of diffractive optics using an almost flat digital one. However, and then what's more interesting, moving to a two-dimensional digital profile opens to a rich variety in the nanostructures, so-called meta-atoms, we can design and select in order to control the properties of light at the nanoscale and manipulate the input wavefront of light beams. However, metasurfaces are much more than just a new design recipe. The possibility to, for instance, to exploit silicon and the well-established techniques of semiconductor manufacturing enables the merging between optics and silicon photonics, and the unprecedented control of light enables the manipulation and combination of its degrees of freedom with the same optical elements. So metasurfaces can promote further the miniaturization, compactness, integration, and also mass production of optical elements with low costs. Metasurfaces are so not just an evolution of optical elements, but actually a revolution in optics, permeating every field of optics and photonics, and inspiring new technological applications from life science to ICT, both at the classical and single photon regimes. With their proliferation, metasurfaces could have a similar impact to transistors in enabling ubiquitous applications through their powerful capabilities and cost economies. Maybe we are still only scratching the surface of potential metasurface functionalities. So now we can start with today's webinar. We thank again all the speakers for joining us, and thanks to all the participants. Many people interested in this topic were not able to participate due to overlap with lessons and didactics duties. So we do thank again the speakers for giving their permission to record the presentation. So those who can be online today, we will be able to find the record of official website. Thank you again to speakers and participants. I leave now the stage to Dr. Andrea Bogliardi, who will introduce the first speaker of the day. Thank you again.